Welcome to the deep dive. Today we're really getting into the weeds on operational safety. Specifically, we're talking about work at height. And we've got something quite interesting here, the actual core curriculum documents from the Pillowit industrial site. So this isn't theoretical. It's a direct look at the real-world requirements. It's like a shortcut for you, the listener, to understand what really matters for safety when you're working off the ground. We're aiming to decode what these 7 key points tell us about a functioning safety system.
Exactly, and that's our mission today. Because looking at these Pillowit sources, it's clear that effective safety isn't just about, wanting to be safe. It's rigorous. It's about documented processes. Gear, structure, administration, they all have to work together. So if you're involved in managing risk, or maybe you just need to understand what real protection looks like versus just ticking boxes, these points show what it takes to prevent a serious failure.
Okay, let's unpack this then. One thing that struck me right away is, well, it seems a bit redundant up front in the curriculum. It lists 2 separate topics. What is work at height? And then the specific definition of the work at height. Why both? Yeah, that looks odd on the surface, doesn't it? But that's where the regulatory detail really kicks in. In these industrial settings, clarity is everything. So what is work at height? That's the broad concept. Any situation where a fall could cause injury, it sets the general scope. But the specific definition, that's the trigger. It's usually a precise distance, maybe 4 feet, maybe 2 meters, depends on the region. That makes all the other fall protection rules mandatory.
Like legally mandatory.
Okay, I see.
So the key thing for you listening is that specific number, the defined height for that site, is critical. If you're an inch below it, technically the full system might not be required, and that's where assumptions and risks can creep in.
Right, so it's the legal line in the sand. Cross that height, and boom, a whole different set of rules apply.
Precisely. That leads us straight into the hardware then, the first big one listed here. Safe use of full-body harness and lifelines.
Now, we see harnesses all the time on sites, but the curriculum really stresses safe use. What are the sort of high-value details we get from this training about actually achieving that?
Well, the insight here goes way beyond just putting the harness on correctly. It's really about the ABCs of fall protection. A for anchor, B for body support, that's the harness, and C for connector, like the lanyard or lifeline.
If any single one of those fails, the whole system is basically useless.
Okay, the ABCs. Yeah, and specifically looking at this Pillowit material, they're really hammering home the technical side of the anchor point. A critical nugget, really, for any high-risk work is the 5,000-pound rule. Every single certified anchor point, the spot where you clip your lifeline, must be engineered and proven to support 5,000 pounds for each worker attached. That's not negotiable. You can't just loop it around any old pipe you think looks strong.
Wow. 5,000 pounds. That's a serious requirement.
It is.
And it shifts the burden, doesn't it? From the worker just finding something to management actually certifying specific points. What about the connector part, the lifeline or lanyard? What are the common mistakes that a rigorous program like this tries to stamp out?
Oh, a big one is managing the free fall distance. It's crucial. For instance, if you take a standard 6-foot shock-absorbing lanyard
Right.
and you anchor it down at your feet, you've already built in a potentially dangerous fall before the shock absorber even starts to deploy. That could be, catastrophic. So a good curriculum, like this one seems to be, forces workers to understand clearance calculation. You absolutely have to factor in the lanyard length, plus the deceleration device deploying that's maybe another 3 to 5 feet, plus the worker's height below the D-ring, plus a safety margin.
Right. The math has to work.
Exactly. If you can't mathematically show that the worker will stop before hitting the level below, that anchor point is unsafe. Doesn't matter how strong it is. The fall distance defines safe use just as much as the gear itself. That focus on calculation is a fantastic point. So, okay, personal gear is the last resort, really. But safety can't just be on the individual. We need to look at the structure itself. Which brings us to the next item. Inspection and tagging of scaffolds.
Inspection makes sense, but why the emphasis on tagging in these high-risk places? What's the operational value?
Tagging, well, it's the ultimate administrative control visually tied to a physical thing. It cuts through any confusion or, he said, she said, green means go, red means stop unsafe. But the real technical detail that this Pillowit training points to is the role of the competent person.
The competent person?
Yes, only someone certified, specifically trained to spot scaffold hazards like, are the tie-offs right? Is the planking secure? Are the base plates stable, especially on soft ground? Only that person can do the inspection and put up the tag. Green, yellow for caution, or red. And if that tag is missing, Or if it's yesterday's date and there was heavy rain overnight, the scaffold is immediately considered unsafe, red, basically. Needs reinspection. It locks in accountability right there on the structure.
Okay, but let me push back a bit. You hear about permit fatigue, right? Having to inspect and tag a big scaffold every single day, especially if crews are just nipping up for a quick job, it could feel like overkill. Does this training acknowledge that temptation to cut corners?
It addresses it by making the process non-negotiable. It's mandatory. Legally binding, usually. If something goes wrong on a scaffold that wasn't tagged correctly or the tag was expired, the company has basically lost its defense right there. So this Pilibit curriculum seems to use the paperwork, the admin, to drive the safety culture. They're essentially teaching that the hassle of doing it right is nothing compared to the cost of someone getting seriously hurt. That visible tag is the constant check against complacency. That makes sense. It forces the discipline, and it links perfectly to the next step, integrating the person and the structure. The topic is use of proper access and fall protection systems.
We've got the harness sorted, the scaffold inspected. Now, the whole system needs to work together. What does proper access mean in this context, beyond just, say, sticking a ladder up?
Yeah, proper access means the journey to the work spot needs to be as safe as the spot itself. On complex sites like Pilibit probably is, access might mean temporary stair towers, maybe mobile elevated work platforms, or even specialized vertical lifelines on fixed ladders. And the fall protection has to be seamless through that access. Like if you're climbing a fixed ladder, you should be clipped into a cable or rail system with a device that travels with you.
Continuous protection.
That's the principle. No point where the worker is unhooked and exposed. It's about making sure you can get from, say, the stair tower onto the work platform and then move to your anchor point without ever being completely untied, eliminating that transition risk.
The transition risk, those moments between clipping points. Okay, so that covers the physical side pretty thoroughly. Now we shift gears into the administrative requirements. You mentioned these can be the trickiest. We've got the mandatory permit to work and supervision requirements, a piece of paper. Why is that so powerful when the danger is, 50 feet up?
Because that permit to work, the PTW, it's the Operational Control Center for High-Risk Tasks. It's not just permission, it forces a structured pause for risk assessment. The supervisor and the worker have to stop and review. What's the exact job? What are the hazards involved? What specific equipment is needed? Who is authorized? For how long? It nails all that down.
Okay.
And the key insight here from the training emphasis is the supervision part. A permit isn't just sign here and off you go. It demands a named, qualified supervisor maintains oversight while the work is happening. They're responsible for checking if conditions change. Maybe the wind suddenly picks up or another crew starts working below. The permit gives temporary authority, and the supervision ensures that authority is used responsibly moment by moment.
And connecting that to the bigger site picture, the permit system must also force coordination, right? Like if there's electrical work nearby, the permit process makes sure those two jobs don't clash dangerously.
Precisely. The PTW is crucial for managing simultaneous operations, what they call CMOPs. And it dictates energy control, too. If you're working near overhead lines, the permit must confirm that power is isolated, locked out, tagged out. It connects the worker up high with the energy control team on the ground.
Okay, but even with the best harness, a perfect scaffold, signed permit, things can still go wrong. Accidents happen. So the curriculum covers the worst case. Documented emergency rescue procedures. This feels like something often glossed over in basic training, but it could be literally life or death. It really could. And it raises a vital question. Why is immediate rescue so critical, even if the person is hanging there, seemingly safe in the harness? The answer is suspension trauma. Suspension trauma.
Yeah, this is where physiology gets urgent. When someone hangs motionless in a harness, especially if they're unconscious or injured, the leg straps can cut off blood flow returning from the legs. Venous return, it's called. Blood pools in the legs, doesn't get back to the heart and brain properly. This can lead to unconsciousness, serious organ damage very quickly. We're talking maybe 5 to 30 minutes before things get extremely critical, potentially fatal.
5 minutes, wow, that's basically no time at all.
No time.
So the rescue procedure requirement isn't just about eventually calling emergency services. It means having a plan, and probably people on site, trained and equipped for rapid retrieval.
Absolutely. The plan has to be specific. Will it be self-rescue, where the worker has gear to lower themselves? Or, more likely for complex sites, assisted rescue, where a dedicated team uses pre-rig systems or other gear to get the person down or up quickly. If the site doesn't have the equipment and the trained personnel and a practiced plan to get that person down within that critical window, their fall protection system is, frankly, incomplete. The training here is demanding proof of a practiced, timed response.
Okay, let's pull this all together then. Looking at this pivot structure, we started with the very foundation defining the risk, the height, then moved to personal gear, the ABCs, the 5,000-pound rule, then structural integrity, scaffold checks, proper access, and finally, layered on the admin and contingency permits, supervision, and crucially, timed rescue plans.
Yeah, and what's really illuminating is how this training implicitly follows the hierarchy of controls. It starts with engineering solutions, designing safe anchors, stable scaffolds, then moves to administrative controls, the permits, the tagging, the supervision, and finally, plans for the what if, the emergency response.
It really lays it out systematically.
It does. The whole structure demonstrates that for these high-risk jobs, safety isn't about intuition or just being careful. It's about rigorous, thought-out, documented processes. Every single step, from defining that trigger height to signing the permit, is designed to minimize reliance on guesswork or momentary lapses.
It's a powerful look at just how thorough safety needs to be. This deep dive into what seems like a standard curriculum really shows it's about paper, process, calculation, training, all working together. And maybe a final thought for you, the listener, to consider. Think about the distinction we made earlier between the sheer physical requirement, that 5,000-pound anchor strength, and the administrative requirement, the permit to work. This Pillabit program structure tells us that even the strongest physical safeguard, that massive anchor capacity, is still ultimately controlled and activated by a piece of paper and a signature. It suggests that maybe the biggest risk in complex operations isn't always the equipment failing. Sometimes it's the administrative system failing.
That's a fascinating point to end on. The paperwork is the key that unlocks, or should lock, the physical system.
Brilliant. Thank you for joining us for this deep dive into the many layers of ensuring safety when working at height. We'll see you next time.